Today we're going to be talking about GCF, which is also called the greatest common factor. And the greatest common factor is going to be the greatest of the common factors of two or more numbers. So in this video, I will be showing you the ladder method to find the GCF. Now in class, we're going to talk about the Venn diagram method, or finding the factors, or writing the factors down, or making a list of factors to find the GCF. But in this video, I will be showing you how to use the ladder method. So to find the GCF, use the ladder method to take out prime numbers that divide evenly from all the numbers. So for example, if I want to find the GCF, or greatest common factor, of 12 and 18, I'm going to think of a prime number that goes in both 12 and 18. So since they're both even, I know that 2 can go. So remember, outside this ladder is only prime numbers. So then I would divide. So 2 into 12 gives me 6. 2 into 18 gives me 9. Then I look at my numbers again. 6 and 9, they're not prime because I know that 2 and 3 can go into 6 other than 1 and 6, and I know that 3 can go into 9 other than 1 and 9. So I will have to do this again, as long as you find a number that can go into both the numbers. So 2 can go into 6 but can't go into 9. But then I think of another number. So I know that 3 is prime and can go into both. So I put 3 on the outside of my ladder and then divide. So 3 into 6 goes twice. 3 into 9 goes 3 times. And then I notice that 2 and 3, I can't do anything else. I can't divide anything else that are in common with 2 and 3. So there I stop. What I'm going to do to find the GCF is I'm actually going to circle 2 and 3. And I'm going to multiply them. So I'm going to multiply 2 times 3. And that gives me 6. So the GCF of 12 and 8 is 6. So if you actually listed out each the factors of 12 and the factors of 18, you're going to find that both lists have 6 in them, and that's the greatest common factor. So another way to remember this is that GCF is just to the left. So you're only multiplying the numbers that are on the left to find the GCF. You can also do this with 3 numbers. So again, I have 4, 20, and 18. I want to find the GCF. So you got to think of a prime number that can go into all of them. So 4, 20, and 18 are all even. So I know that 2, since 2 is prime, it can go in all of them. And then I divide. So 2 into 4 is 2. 2 into 20 is 10. And then 2 and 18 is 9. So then I look at my numbers. Well, 2 is prime. 10 is composite, 9 is composite, but there's not going to be a number or a prime number that can go into all of them. So therefore, I stop. So again, GCF is just to the left, which is 2. So the only number that I circle is 2, and that's it. That is all I do, is just 2 itself. So the greatest common factor of 4, 20, and 18 is 2. Okay? So let's do a little bit more, trying some together. So find the GCF of 15 and 45. So again, I'm going to write my upside down division symbol using the ladder method. I'm going to put 15 and 45 into the ladder. And then I'm going to think of a prime number that can go into both 15 and 45. So what can go into 15 and 45 that's prime? Well, on my prime, 2 can't go in because they're not even. 3 can go into both 15 and 45. The other prime number that I could use is 5 because both numbers end in 5. And I can divide both by 5. So if you weren't sure that 45 is divisible by 3, do 5 because both of them end in 5. So let's pull 5 out. Then I'm going to divide. So 5 into 15 goes 3 times. 5 into 45 goes 9 times. Well, I can keep going because even though 3 is prime, 9 is composite, I know that I can divide 3 divided by 3 and 9 divided by 3. So I can use 3. So 3 into 3 is 1. 3 into 9 is 3. So what am I going to do is to find the GCF using the ladder method is I'm going to circle the numbers that make up the left of the ladder. And all I'm going to do is multiply 5 times 3. So the GCF of 15 and 45 will be 15. Okay? So if you even listed all the factors of 15 and all the factors of 45, you notice that both the list will have 15 and that'll be the greatest common factor. All right, so let's try 3 numbers this time. So again, you have your upside down division symbol. I'm going to put in 16, 24, and 72. Then I'm going to find a prime number that can go into both of them. Well, they're all even, so let's try 2. So 2 into 16 gives me 8. 2 into 24 gives me 12. 2 into 72 gives me 36. Well, I can keep going because they're all composite. And 2 can go into all of them. 2 into 8 gives me 4. 2 into 12 gives me 6. 2 into 36 gives me 18. I can keep on going because 2 still goes into all of them. So 2 into 4 gives me 2. 2 into 6 gives me 3. 2 into 18 gives me 9. And I'm going to stop right there because 2, 3, and 9, there's not a number that can go into all of them. So I stop. So then I circle all the numbers that are just to the left to find the GCF. And then I'm going to multiply those numbers. So I'm going to multiply 2 times 2 times 2. So therefore my GCF of 16, 24, and 72 is 8. Okay. All right, so I showed you how to do the ladder method using for the greatest common factor. Now we're going to apply this to GCF word problems. Okay. So with GCF word problems, you have to know some key words in order to know it is a GCF word problem. So what GCF word problems will be asking you in a word problem? To split something up, okay? So it has to do with splitting things into smaller sections, okay? To equally distribute sets of items into their largest groups, okay? To figure out how many people we can invite, so for instance, to a party. Okay, to arrange something into rows or groups. Okay, that's how you know it's a greatest common factor problem, a word problem. Okay, it has to do with greatest common factor. Okay, so you want to look at some keywords in the problem. So think of if you're splitting things into smaller sections. Think of it if you're equally distributing things into their largest grouping, and then how many people are you going to invite, or how you're going to arrange something into rows or groups. So let's go to example number 1. It says, Mr. Williams has 120 crayons, 30 pieces of paper to give to his students. What is the largest number of students he can have in class so that each student gets equal number of crayons and number of paper? So this has to do with putting things into groups or splitting things into equally. And I want to figure out what the largest number of kids I can have in my class. So the key word here is largest. So given that information, I know this is a GCF problem. So I'm going to find the GCF to figure out how many kids or how many students he can have in his class. Okay? So using the ladder method, I'm going to find the GCF of 120 because I have 120 crayons and 30 pieces of paper, so that each student is going to get an equal amount of paper and crayons. So again, 120, 30, what prime number can go in that's outside? I can do 20 because both of them have a 0 and they're even. So 2 and 120 will give me 60. 2 and a 30 will give me 15. All right. Now I got to figure out another number. Okay, 2 can't go into 15, but can 60, but can 3 go into both? Yes. So I'm going to do 3. All right. 3 into 60 goes 20 times. 3 into 15 goes 5. I got to keep going because there is a number that can go into both 5 and 20, and that would be 5. And 5's prime. So 5 into 20, 5 into 20 goes 4 times. 5 is 1. And I stop. So again, with GCF is just the left. So to figure out how many students I'm going to have in my class, I just multiply 2 times 3 times 5. So 2 times 3 times 5. So 2 times 3 is 6. 6 times 5 is 30. So my GCF is 30. So that means he can have 30 students. So the question is, what is the largest number of students that he can have in his class? And we label it 30 students because that's our word problem. Let's look at example number 2. It says, I am planting 50 apple trees and 30 peach trees in rows. I want to mix the apple and peach trees in my rows, and I want each row to be the same. What is the maximum number row I can plant? So again, I'm putting things and arranging things into rows. So whenever I'm arranging things, it's going to be GCF. So again, the 2 numbers I'm dealing with, I'm finding apples and peach trees. So I'm going to put these into my ladder, 50 and 30. Okay. And again, the other word that's a key word is maximum. Okay. What's the max I can do? So 2 can go into both 50 and 30. So that's a prime number that can go. 2 into 50 is going to be 25. 2 into 30 is 15. Okay. 5 goes into both 25 and 15. So 5 into 25 is 5. 5 into 15 is 3. And I stop there because nothing else can go into both. So I circle the 2. 2 times 5. So 2 times 5 is going to be 10. And we're talking about, going back to the problem, I'm asking what is the maximum number of rows I can plant. And we can plant 10. What is the maximum number of trees I can plant per row? So we say 10 trees per row. Okay? So again, this was greatest common factor, dealing with using the ladder method.